Okay, I got my letters mixed up, I'm afraid. Let's go with the green here. Oh, forest green. What did I do to both? So I got these are mixed up. So this should, what I meant to say here was, so it's the plane, and you can imagine it as a flat piece of paper that kind of goes like this, it contains this point, and it contains this triangle. So it's parallel to not U and V, but it's parallel to V and W. So sorry, I screwed that up. So it goes through U, and it's parallel to these two vectors here. Okay, moving on. Now we can talk about our solution sets in a visual way. Okay, and through example, of course, let's talk about a system x1 minus 2x2 plus 5x3 equals 0. We're going to talk about a system that has all zeros on the right-hand side. Okay, what else? Minus x1 plus 2x2 minus 5x3 equals 0. Take a second to double check I copied it down right. Always worth your time to double check that you copied the question down correctly. It's a painful mistake to have to correct. Okay. Okay, notice that it's all zeros. The right hand side, all zeros there. So this is called a homogeneous system. AX is equal to 0 if you wrote it as a matrix equation. So let's try to solve this system. All right. So of course we're going to put it into a augmented matrix. Looks like 1 minus 2, 5, 2 minus 4, 10 minus 1, minus 1, 2 minus 5, 0, 0, 0. Okay, double check that I put everything in there correctly. Okay, start row reducing. Yeah, okay. So it's going to be row 2 minus 2 row 1, row 3 plus row 1. Okay, I'm going to get 0, subtract twice 0, subtract twice 0, 0. Oh, it's the same. 0, 0, 0, 0. So I see that I have two free variables. So if I convert this back into an equation, I get x1 minus 2x2 plus 5x3 equals 0. Now, what was my process? My process before was to solve for the basic variable in terms of the free variables. Okay, I do that. Then you'd say x2, x3 are free. Okay, so that is called the general solution. So we're going to take this a bit further. And we're going to replace free variables with parameters. Okay, like above where I had s and t. We'll say x2 is s. Doesn't really matter. x2, oh, it's a weird s. x2 is s. x3 is t. And what do you get? You get x1 is equal to 2s minus 5t. And I'll say we form parametric vector equation. Okay, here we start with the vector x1, x2, x3. And we make this replacement here and also these replacements here. Okay, I'll leave the left-hand side alone. The right-hand side I will pull apart. What do I get? I get s. Let's just do it in 2 steps. 2s, s0 plus minus 5t, 0t. So I'm just decomposing the right-hand side. Okay, left-hand side, don't touch it. Factor of the s, 2, 1, 0 plus t times minus 5, 0, 1. Now this is the this was called the parametric vector equation of a plane, or the parametric vector form of this solution. Sometimes you call this vector just x. X is equal to s u plus t. Let's go with v and w like I had above, sv plus tw. Okay, so this is called the parametric So it's a parametric vector form for our solution set. Okay, so it gives a description of all the solutions to the original system. And it gives it in terms of something visual, right? This is the plane through, well, you'll notice here there's no vector u like we had above. So it's actually the plane through the origin. That is parallel to 2, 1, 0 and -5, 0, 1. So that's our geometric description. of this solution set.